plaisir aujourd'hui d'accueillir David Caplan. David Caplan est professeur de neurologie à la Harvard Medical School et à l'Université de Boston. Il a en outre une activité de neurologue praticien. Il a publié entre autres deux importants ouvrages. L'un, une somme sur la neurolinguistique et la physiologie, Neurolinguistics and Linguistics and Physiology en 87, et un ouvrage très connu avec Nancy Hildebrandt, Disorders of Syntactic Comprehension. Il a beaucoup travaillé sur la modularité des ressources impliquées dans le traitement syntaxique durant toutes ces années. Je vous remercie.
Well, firstly, I want to thank the organizers for inviting me. And secondly, I want to apologize for reading this talk. This is a new topic for me, and I did not feel comfortable trying to reconstruct the talk just from slides. I thought that the disadvantages of reading it would be outweighed by the potential clarity of what I had to say. And thirdly, I just wanted to say that this first talk is a very broad talk without a lot of strong empirical data. The second talk I'm going to give today would be much more sort of characteristic of basic scientific talks. But I thought I would choose this topic firstly because it's been a long-standing personal interest, and also because I thought it would describe in very broad terms some of the issues in the relationship between the concepts of representations that come up in psychology and philosophy and neurological considerations. So, to start with some basic premises, I assume that the term representation is a construct in psychology, and that psychology is a special science with its own theoretical vocabulary. I also assume that the relation between constructs in psychology and neurology is non-causal, as best we know today, and is best captured by functionalism, which maintains that psychological operations have a physical basis, but not necessarily a neural one, that a silicone-based machine could, in principle, support the same cognitive system that a neural carbon-based machine does. It is a point of logic that even if a non-causal relation between psychology and neurology, such as functionalism, is correct, human psychological processes must be consistent with properties of neural systems. Furthermore, at least in principle, studying neural correlates of representations might provide information about them. Now, views regarding the importance of neurological considerations for psychological models have changed radically since I was a graduate student, and the change is closely linked to changes in psychological theories themselves. The type of psychological model that was most utilized in the 60s and 70s assumed that cognitive primitives could be represented as unitary symbols, and that these symbols were related through various types of rewrite rules. I'm going to call these symbolic procedural models. These theories made use of computer analogies to the extent that they made use of any physical analogy whatsoever. Psychological predicates were like the software, the brain was like the hardware, and as far as I can see, almost no thought was given to what types of software could run on neural hardware. These models largely ignored information about neural elements and systems. For instance, there's a very famous quote from Chomsky in '94 that runs as follows: "How can a system such as human language arise in the mind-brain, or for that matter in the organic world, in which one seems not to find anything like the basic properties of human language? That problem has sometimes been posed as a crisis for the cognitive sciences. The concerns are appropriate, but their locus is misplaced. They are primarily a problem for biology and the brain sciences, which as currently understood do not provide any basis for what appear to be fairly well-established conclusions about language." And in contrast to this perspective, many more recent models, first widely adopted in psychology after the 1986 PDP books, have properties that are inspired by neural considerations. Advocates of these models often argue that they are preferred to symbolic procedural models because they are neurally realistic. It is sometimes claimed, and often felt, at least where I live, that symbolic procedural models are inconsistent with neural reality, which would necessarily, if true, entail that they are wrong. These authors see Chomsky as allocating the crisis to the wrong field. So in this talk, I'm going to basically review some properties of procedural symbolic models, some properties of connectionist models, and then turn to some neurological considerations. About 2/3 of the talk, I think, is going to turn out to be about psychology, and about 1/3 about neurology. Now, starting with procedural models. Symbolic procedural models have been developed in very many areas of cognitive psychology. For instance, almost all models of linguistic structure and many models of language comprehension and production are of this sort. The broadest framework for accounting for the nature of cognition and its role in determining human behavior is basically relies on symbolic procedural models, and I think can be characterized as one or another form of the representational theory of mind. The representational theory of mind holds that cognitive psychological states consist of maintaining a propositional attitude. A lot of what I'm going to say in the next few minutes was discussed in one way or another yesterday in the session on theory of mind. Propositional attitudes being statements of the form X believes, wants, expects, knows P, where X is an individual and P is a proposition. Holding propositional attitudes and relating them in their embedded propositions to one another constitutes cognitive activity and is the basic mechanism whereby people bring cognition to bear on action. Now, RTM is not a single theory, but as Fodor described it, a loose confederation of ideas, and I'm going to present Fodor's version of it for the next 5-10 minutes. In his view, the following 3 statements capture the essence of the theory. Psychological explanation is gnomic and intentional. Mental representations are primary bearers of intentional content. Thinking is computation. The first of these statements says that psychological laws are laws, like any other laws of special sciences, and that they are intentional. The second says that a propositional attitude includes a mental representation of the proposition P that is the content of that attitude. Propositions themselves relate concepts. To believe that dogs bite is to entertain the concepts dog and bite and a relationship between them. Mental states therefore consist of intentional relations to relations among mental representations of concepts. Thesis 3 states that thinking is computation. In more elaborate form, according to Fodor, thinking is the iteration of, quote, causal relations among symbols that respect semantic properties of the relata. Causal relations among symbols that respect their semantic properties occur because at its basis, the mind-brain operates as a Turing machine in which the next operation of the machine is based on the state the machine currently is in and the symbol that it's reading. The computations in representational theories of mind are purely syntactic. They're determined by the representations in each domain, not the content of those representations. This concept of computation is extremely broad. Though it limits computations to causal relations that respect semantic properties, it does not limit them to causal relations that are truth-preserving. Thus, association is a computation on this model. To flesh this out a little bit, an example of the way this works would to imagine Jones walking down the street and seeing a man with a dog. Jones knows that dogs bite. He holds a propositional attitude. And he crosses the street to avoid them. And his mental processes run something like this. He thinks dogs bite. He thinks biting requires proximal contact. He thinks if I cross the street, dogs won't bite me. And this line of inference leads him to the action of crossing the street. It's also possible for Jones to have an association to the dog. He might think of dog food, and he remember that he has to buy dinner, and then he might which might lead to an action later on in the day. So all of these types of computations are the genesis of actions. I see these just incidentally, I see these 2 types of operations, entailment and association, as playing 2 completely different kinds of roles in human psychology. Entailment and inference are the basis for rational thought, justifiable belief, including science, and many successful actions, including the applications of science, and association contributes to creativity. This framework, this representational framework of mind, the theory of mind framework, requires characterizations of the concepts that are related in the propositions that are the content of propositional attitudes, and of the rules that relate these concepts to form these propositions, among others. So let me turn briefly to those two aspects of the model. Concepts. Fodor again advocates proposes three premises or assertions about concepts. That concepts apply to things in the world. The concept dog is one which, of necessity, all and only dogs fall under. Concepts are word meanings. The concept dog is what the word dog and its synonyms and translations express. Concepts are constituents of thoughts. To think that dogs bark is, among other things, to entertain the concept dog and the concept bark. The first premise deals with the content of a concept. Fodor's view is intuitively appealing, but it has proven very hard, Fodor says impossible, to specify representations of concepts that capture the feature that they apply to all and only their instances. The classic Aristotelian view that the representation of a concept is the set of properties that are individually necessary and jointly sufficient to characterize items in its extension did accomplish that goal, but it has encountered many very well-known problems. The Wittgensteinian observation that no examples of severally necessary and jointly sufficient features have ever been provided, that there's no principal distinction between features and concepts, that there does not seem to be a way to identify the set of primitive concepts or features, that the hypothesized features of a concept never seem to be activated in any psychological process. Alternatives to the Aristotelian view, which fall into two broad categories of inferential role semantics and information models, all have other limitations. Fodor, in many places, more or less throws up his hands and says that the content of a concept is whatever the mind locks or resonates to when presented with prototypical instances of the concept. That basically, in his words, the content of the concept dog is dogginess. Premise 2 states that the concept dog is what the word dog and its synonyms and translations express. This relates concepts to language. It points to the important fact that there is more to a concept than its content, a conclusion that has been familiar at least since Frege. As Frege pointed out, the evening star and the morning star are coextensive and therefore have the same content by premise 1, but they are not the same concept. The reason that you can see that they're not the same concept is that they cannot substitute and preserve meaning, and necessarily preserve meaning in intonational contexts. It is possible for John to believe that the evening star is the evening star and not believe that the evening star is the morning star. Therefore, different coextensive terms must be different concepts. Frege proposed that words had sense and reference. He suggested the sense of an expression is the way in which one conceives of the denotation of the term. He proposed that when a term follows a propositional attitude verb, it denotes its sense and not its referent. In Frege's system, while John believed the evening star is the evening star and John believed the evening star is the morning star have the same truth value, they are different propositions and ascribe different thoughts to John because the senses of the evening star and the morning star differ. In Frege's system, terms with the same sense are synonyms. But synonyms also encounter problems of substitution salve veritate in so-called mates contexts. Pupil and student are arguably synonyms, but it is possible for Bill to wonder whether John understands that pupils are students, even though Bill does not wonder whether John understands that pupils are pupils. Fodor says that what is added to a concept aside from its referent is its mode of presentation. And he goes on to say that if it is stipulated that modes of presentation are whatever substitution salve veritate turns on, then modes of presentation have to be sliced a good deal thinner than senses. Individuating modes of presentation is more like individuating forms of words than it is like individuating meanings. Modes of presentations have roles in the operations of the theory of mind as I outlined it above. The same mode of presentation can play the same mental role in two people even if the concept it refers to the concepts it refers to are non-coextensive. For instance, Someone who thinks that Jill's new boyfriend is Bill and someone who thinks it is Henry can discuss many topics about Jill and her new boyfriend without realizing they are not referring to the same person. It's the phrase Jill's new boyfriend, which is mentally active and causal, not its referent. The best known example of a causal role of a mode of presentation in psychology is imaginary. It is water on Hillary Putnam's twin Earth and water on this Earth. Okay, to summarize, premises 1 and 2 lead to the view that, this is Fodor again, a concept is a mode of presentation together with a content. The content of a concept is a gnomic relationship between the concept and some set of items or events in the world. Modes of presentation are mental objects that have semantic content and play causal roles in the rules that combine representations in the propositions and propositional attitudes. I think a strong case can be made that the lexical items of a language are the mode of presentations for elementary concepts. Modes of presentations capture both what Frege's theory of sense and Turing's notion of computation require, a fact that Fodor says is one of the most important convergences in modern psychology. Basic concepts and unanalyzable modes of presentation are unitary, not constellations of individually necessary and jointly sufficient features. Okay, turning back to the third premise of the theory of mind, that that thinking is computation. Fodor fleshes this out by saying that concepts are constituents of thoughts. Let me see if I have that. No, okay, sorry. So I'll just read this. Concepts are constituents of thoughts. To think that dogs bark is inter alia to entertain the concept dog and the concept bark. To think that dogs bark also requires that one be able to combine the concepts dog and bark to form the proposition dogs bark. This is one aspect of computation in the representational theory of mind. Computations have properties that Fodor describes as compositionality, systematicity, and productivity. If you understand the boy pushed the girl, you must be capable of having the thought that the girl pushed the boy. Note that this capacity does not depend on preservation of truth. Asymmetry of action is the rule. Nor does it depend on epistemic factors. Even if it is true that the girl pushed the boy, you may never have evidence that this is the case. It is simply a property of the human mind that if it is possible for a person to represent the boy pushed the girl, it is possible for him or her to represent the girl pushed the boy. Compositionality, systematicity, and productivity immediately follow from the view that a person who has the thought, the boy pushed the girl, has a rule that represents a relation between the representations of the, boy, girl, and push, which allows the, boy, girl, and push to combine in more than one way. Because systematicity and productivity are general properties, the relationship between the ability to have the thought the boy pushed the girl and the girl pushed the boy applies to an infinite number of concepts that can substitute for the words in those sentences. The rule establishes a relation not between representations of specific concepts, but between higher-level characterizations of concepts. These higher-level characterizations of specific concepts and the rules could take many forms. The higher-level characterization of concepts could be superordinate levels of a concept hierarchy, and the rules could look like formula in a predicate calculus, something like this. Linguistics provides candidates for these higher-level characterization of concepts in the form of syntactic categories and candidates for rules that relate them in the syntactic structures of a language. Lexical items are assigned syntactic categories informally known as parts of speech, and syntactic structure consists of hierarchical trees of these categories with the relations of dominance and sisterhood in which the terminal symbols dominate lexical items. Different relations among nodes allow different semantic relations to be established between lexical items they dominate, and very small differences in paths across node in a tree affect interpretability. So in a tree like this, the object of the embedded clause can be co-referential with the pronoun in the matrix predicate, but it can't bear a thematic role to the verb of the matrix predicate, even though the the path over the tree is extremely similar. Syntactic structures, I'm going to say a word about syntactic structures, only a word. They interface with expression and perception. They therefore map meanings onto sequences of words, and the mapping is many to many. The same meaning can be mapped onto different word sequences, for instance, thematic roles in actives and passives. A given sequence of words can be ambiguous, and word sequences and other surface forms encode several aspects of meaning. For instance, the sentence initial NP can be the agent of a verb phrase and the focus of a discourse. One way to characterize the surface form of syntax and morphophonology is as a compression of multiple aspects of meaning into a linear signal. A major issue in theoretical linguistics is how syntactic representations capture this compression. All options involve an extremely complex set of rules that relates concepts and propositions to surface forms of phrases and sentences. Syntactic structures and morphology provide rules that can account for some of the combinatorial properties of concepts. The question of whether these representations support thought has largely been answered negatively by people like Fodor and Pinker. They have a lot of objections to this idea, and the most important one seems to me that mental content is ultimately unambiguous, so the meanings of unambiguous sentences must themselves be unambiguous. However, the unambiguous of mental representations is only incompatible with an unannotated surface structure being the entirety of the representation of a sentence. A conceptual level of language such as logical form would be a possible language of thought. A sufficiently annotated surface structure can also be unambiguous and could be a form of thought. A viable position, I believe, is that syntactic and morphological operations underlie the combinations of word meanings at the propositional level. The language of thought is unambiguous and therefore is not spoken English or any natural language, but some of its properties are very likely to derive from natural languages. Now, others clearly cannot. For instance, inferences based on propositional meanings are not derived by combinations of concepts based on syntactic rules or any other rules of language. Because of this, many aspects of discourse structure are not created by the applications of rules of language. As I mentioned above, an important set of these preserve truth, and these include rules of valid inference. I'd like to emphasize that such rules cannot be learned by inductive generalizations, a point that's relevant to connectionist models. Over observed instances. For instance, consider the following rather simple syllogism. Some plumbers are electricians, some electricians are carpenters. The conclusion that some plumbers are carpenters is not valid. And this, the reason it's not valid can be seen in the following Venn diagram. And this could be endorsed by a person who has only happened to encounter plumbers who happen to be carpenters. To summarize, the representational theory of mind holds that psychological laws are intentional and that mental states consist of propositional attitudes in which the propositions relate concepts. Concepts connect nomenclaturally to items in the world, though how they do so remains mysterious. The content of a concept is not the aspect of the concept that plays a role in mental computational processes, but plays such a role as how the person grasps the concept. There seem to be at least as many ways of grasping concepts as there are lexical items and their combinations, the modes of presentations of concepts. Words are the modes of presentations that play such causal roles. The syntactic operations of language allow the combination of concepts into phrases and into the propositions and propositional attitudes. These operations, like those of valid logic and mathematics, consist of rules that operate on symbols. Now, alternatives. There are many points of vulnerability in the picture that I just outlined. One set of objections, I saw any number of people shaking their heads negatively at many points in the exposition. One set of objections would be called internal. I hope that all of you who are shaking your heads have internal objections. These type of objections accept the basic idea that mental and psycholinguistic operations include symbolic representations of concepts and combinatorial rules, but they dispute particulars of the models that I outlined. I have no idea why you were shaking your heads, but for me, the biggest problem is that almost all the aspects of the model I just outlined derive exclusively from philosophical and linguistic considerations and make almost no contact with studies of perceptual identification, comprehension, and production of words of sentences. And alternatives to these types of representations have arisen within each of these disciplines that are not endorsed by linguistic theory or philosophy, such as, for instance, Vashish and Lewis's particular version of X-bar theory for phrase structure in their implemented parser. The second set of objections is much more fundamental. It rejects the notions of unitary symbols and combinatorial rules. It sees mental activities as probabilistic and associative down to their core. And I'm going to outline one sort of statement of this view from Spivey's book on the temporal dynamics of mental functioning. That's a 2007 book, which is how he describes representations. And this, I think, will really make some of the differences pretty clear. He says, the term representation need not refer to an internal mental entity that symbolizes some external object or event. The word can refer to a kind of mediating stand-in between sensory stimulation and physical actions, which is implemented largely by neuronal assemblies that never settle into truly stable states. The bottleneck that converts fuzzy, gray, probabilistic mental activity into discrete, easily labeled units is not the transition from perception to cognition, contra cognitive psychology. Rather, that conversion does not take place until the translation from motor planning to motor execution. So there are many models that fall into this type. The best known and most widely used in cognitive psychology are connectionist models and dynamic state and phase models. Developers of probabilistic models have claimed that these models are superior to symbol-based procedural models in understanding a wide range of psychological phenomena. So the next 10 minutes or so, I'm going to say a few things about the psychological phenomena that they model and that they don't model, just from my point of view, where their successes lie. Now, I find it very instructive, always found it very instructive, to consider the areas in which success has been claimed. Couldn't do a complete review of work using these approaches, but I compiled a list of what I think must be representative areas of study from three relatively recent sources: Spivey's book, Joyce and McClellan's Review of Studies of Language in 2015, and Roger and McClellan's 2014 introductory review to a special issue of Cognitive Science celebrating 25th anniversary of connectionism. By my count, Spivey reviewed 9 simulations, Joyce and McClellan reviewed 7, and Rogers and McClellan reviewed 25. Almost all of these simulations dealt with single items. A small number, 5, dealt with structural relations over time, and a portion of these was presented as showing the capacity of connectionist models to extract what were called syntactic-like relations among words and sentences. So the work dealing with single items, I think, has been most successful. It has been directed to 2 phenomena that are related. One is extracting patterns in what are called quasi-regular domains, such as spelling sound correspondences and past tense formation in English. And the second is modeling interactions between factors that determine categorization, interpretation, aspects of memory, naming, and other behaviors. These models have greatly expanded our understanding of possible ways that structure may be extracted from stimuli in a domain, and that factors might interact. They have done much to dispel the encapsulation view of processing that is associated with Fodor's theory of modularity. Having said that, many of the best developed models of processing single items are highly controversial. Whether reading aloud, for instance, is best modeled by a fully distributed parallel interactive model or by a 2-root model remains a topic of intense debate and research. And some problems in this domain, such as the assignment of lexical stress in English, are very hard and have not been approached. That interests me particularly because I know Mark Seidenberg well. I was with him at McGill in 1988, and he and I discussed at that point the idea that reading was a secondary feature of human language processing, and a much more challenging and interesting area to try to simulate would be the assignment of past tense, and he said he would get right onto it. There's much less work that deals with extracting structure from sequences of items, and very little pertaining to extracting structure in domains that, from the point of view of symbolic models, involve hierarchically organized categories. I was going to review work dealing with the combination of concepts into higher order concepts, but I decided that I was want to risk overrunning my time, so I'm going to drop all of that, and if I have time at the end, I can read a page of this. And I'm just going to talk about work dealing with the relationships between items in propositions. Frankly, I find very little success here. There are a very limited number of studies. Work by Ellman has been showcased for 15 years, and again referred to in the reviews I cited above, as providing an example of the ability for current nets to extract syntactic structure. But Ellman's model deals with an extremely limited range of structures. Christensen and McDonald in 2002, is a paper that's rarely cited, they reported training of a simple recurrent network to predict the next word in a sentence. This model had a number of successful predictions. For instance, it made more errors predicting verbs of object-relative sentences than other words, but it made many false and ungrammatical predictions that were never made by humans. The most recent work on this topic, which is more than cited, it's showcased by Joannis and McClelland, is by Socher and his colleagues, I don't know how to pronounce the name, who developed a parsing model using multiple hidden layers that mediate the relationship between input and output, the so-called deep learning model.